Well, um, today we are going to learn about multiple comparisons. Last class আমরা পড়েছিলাম ANOVA. ANOVA-তে আমরা several mean test করি, whether those means are equal or not. If in that F test, that is in ANOVA test, null hypothesis is rejected. That means that the means are not equal. Okay, those means are at least 3 means. Okay, so the question arises, which pair of mean are different? That is, multiple comparisons comes in. A multiple comparisons test all possible pair. Okay, so if you have 3 means, then we have 3C2, 3 combination 2, so 3 pairs. Okay, if you have k means, that is k groups, then we have kC2, so k into k minus 1 by 2. That will be the number of pairs we want to test. Okay, so when the ANOVA test shows us a significant different results, statistically significant different results, then we have to do that multiple comparisons, that is, which pair are different. So that is multiple comparison. In multiple comparisons we have many tests. Okay, many tests. We have Bonferroni methods, we have LSD. Among those, LSD is the latest one, and LSD is most widely used, so we'll learn that. LSD means least significant difference. It actually very equivalent to a T distribution. LSD for I and J pair would be mu I hat minus mu J hat subtraction divided by that S of mu I hat minus mu J hat. That is, this is S. This is a standard error. Okay, and on top, that is in the denominator, you're saying that mu I mean, Z group mean. So you have to subtract these two mean and divide it by their standard error. So this is very simple. Okay, you will have the estimate of the mean from the sample. গত ক্লাসে যেমন আমরা পড়েছিলাম, 3টা ফার্টিলাইজার ছিল, কাজেই 1 2 3 3টা গ্রুপ, mu1 mu2 mu3, তাদের এস্টিমেট, যেটা y1 বার, y2 bar, y3 bar. That is, your estimate for mu I hat is equal to y1 bar. Okay, y2 bar if you want to compare first and second group. If you want to compare the first and third group, that is 1 I equals 1, J equals 3, or 2 and 3. So when you have 3 groups, you have 3C2, 3 possible pair. Okay, so you have to test all this. Testing is very similar to T distribution, T test. What is it? You have to find the LSD value, LSD calculated based on this formula, and from the table we will get a value of T alpha, that is T tabulated. If this T calculated is greater than that T alpha, that is T tabulated, null hypothesis is rejected. Here the hypothesis is that these two means are equal, mu I equals mu J. Alternative hypothesis mu J, mu I is not equal to mu J. Okay, so if your null hypothesis is rejected, you will understand that these two means are different. Okay, so that is the way of producing LSD, that you have to pair all possible pair. You have to find the LSD for all possible pairs, okay? And that testing. So for calculation, you have to calculate this S. This is sample standard deviation. When you calculate it for sample, it is actually called standard error. So this is the formula of calculating the S, okay, for mu I hat minus mu j hat. So this is the formula that MSC into 1 by Ni plus 1 by Nj. These n's should be a small n, okay? আপনারা এটাকে small n হিসেবে লিখবেন। A small n টা কি? Sample size in the ith group, sample size in the j group. গত ক্লাসে আমরা যে এক্সাম্পল বলেছিলাম সেখানে প্রত্যেকটাতে 5 করে স্যাম্পল ছিল, কাজেই আপনার Ni এর মান হচ্ছে 5, Nj এর মান হচ্ছে 5। ওকে, MSC টা কি? MSC হলো মিন সাম অফ স্কয়ার ডিউ টু এরর। গত ক্লাসে আপনারা ক্যালকুলেশন করেছিলেন, মনে আছে কিনা? যেটা ছিল উইদিন মিন সাম অফ স্কয়ার। উইদিন সাম অফ স্কয়ার কে যখন ডিগ্রিজ অফ ফ্রিডম দিয়ে ভাগ দেন তখন সেটাই হলো আমাদের MSC। কাজেই on the way of ANOVA you will produce this MSC. So calculation of LSD, if needed, it is readily available actually, because the mu's are given. You calculate this mean first, then you will calculate this MSC too for producing ANOVA. Okay, so producing that S and then LSD will be easier for you for each and every pair you want to compare. Forget not, if you have 3 groups, then you have 3C2, that is 3 pair. If you have 4 groups, then you have 4C2, that means 6 groups. So then you have to find the LSD for those 6 groups too, okay, to see what are those pairs that are significantly different, and what are those pairs who are not, which are not, okay? So that is the LSD. So when you learn about test of hypothesis, you learn this too. গত ক্লাসে আমরা একটা এক্সাম্পল দিয়ে আপনাদেরকে ANOVA বুঝিয়েছিলাম। যারা ছিলেন, most of you should be in the class. So fertilizer 1, fertilizer 2, fertilizer 3 ছিল, তাদের আপনি মিন বের করেছিলেন, if you can remember. Y1 bar 77 ছিল, 68 ছিল, Y2 bar, and Y3 ছিল 80. So this is the estimate of mu1 hat, mu2 hat, mu3 hat, okay, estimate. Actually this is coming from the sample Y1 bar, Y2 bar, Y3 bar. So these are actually the item we are looking for, okay. আপনারা আরো বের করেছিলেন this MSC, this is MST, treatment. আমাদের LSD আজকে ক্যালকুলেশন করতে গিয়ে লাগবে সেই MSC হচ্ছে এইটা, okay. On the way you calculated yesterday all this. So this is only needed when your ANOVA hypothesis is rejected, otherwise not, okay. If you get that your null hypothesis is accepted in ANOVA, that means that all the means are equivalent, then you don't need to calculate LSD. You don't need any multiple comparing, okay. Got it? You need this if and only ANOVA hypothesis, ANOVA null hypothesis is rejected. That means they are not different. Sorry, they are not equal. They are different. So you then need which pairs are different and which pair are not. We calculated this multiple comparison, that is LSD, using the SPSS software. You will produce that manually in hand using the formula I showed you just few minutes ago. So that is I, that is Z. Okay, these are the groups you have. We have three groups, so we have 1, 2, 1, 3, 2, 3. These are the three groups we needed. But computer calculated all possible ways, so it has a repetition. Okay, 2, 1. This same thing on 2. Okay, 2, 3, 3, 2. These are the repetition. So you need only that three groups: 1, 2, 1, 3, 2, 3. Okay. Firstly, if you see that 1, 2, it is showing that your significance level is significant value, that is 0.012. It is calculated by computer. Okay, so they calculated that p-value here. So if this p-value is less than 0.05, null hypothesis is rejected. So it is for smaller than 0.05. So 1, 2, group 1 and group 2, the mean of fertilizer 1 and mean of fertilizer 2 are significantly different. 1, 3 বেলায় significance value হলো 0.342, much higher than 0.05. So null hypothesis that mu1 equals mu3 is accepted. That is, mean of first group, mean of third group are similar, are equivalent. So we have another pair, that is 2, 3. Okay, 2, 3 significance value is 0.002. So it is highly significant. So your null hypothesis that mu2 and mu3 are equal is rejected. That means mu2 and mu3 are significantly different. Okay, so that is our goal in LSD, that we now know that fertilizer 1 significantly different from 2, fertilizer 2 significantly different from 1, and from 3, fertilizer 3 significantly different from 2, that is said earlier. So we got this calculation that 1 and 2 are significantly different, 1 and 3 are not, 2 and 3 are significantly different. Okay, so this is the findings of multiple comparisons. We used LSD here. LSD is the most popular method of multiple comparison, so you will use this multiple comparison too. Do you have any question?
No, sir.
Forget not that significance value, these values you will not get in your exam. Okay, but if you do some further research, you will know that you will use some softwares, and using those softwares these values will be provided. But here you have to do some manual calculation that I showed you. That is LSD, you have to calculate this value. This is also T, I told you. So this is calculated value of T. You have to go to that T distribution table to find that critical value using the alpha and the degrees of freedom in Manat J. So from there you will decide whether your null hypothesis is rejected or accepted. So that is the multiple comparison we want to learn today. Our next topic is nonparametric test. Our next topic is nonparametric test. Nonparametric test is actually different from parametric test in a way that we had some assumptions in Z distributions, in T distributions, chi-square distributions, and F distributions. We actually studied in some classes earlier. Okay, so those distributions are parametric distributions: T distribution, chi-square distribution, F distribution, and Z distribution, that is normal distributions. So while testing those test statistics, we had some assumption that the data is actually following normal distribution approximately. Okay, so if that assumption is violated, that is, the data is not following normal distribution, that is the non-parametric test when we need it. Okay, in a smaller sample size, usually the assumption of normality is violated. Okay, then we need non-parametric tests. Occasionally, the assumption of the t-tests are seriously violated. In particular, if the type of data you have is ordinal in nature and not at least interval, in such occasions, an alternative approach is to use non-parametric tests. Non-parametric tests are also referred to as distribution-free tests. Okay? এই টেস্টগুলোকে ডিস্ট্রিবিউশন ফ্রি টেস্ট বলে, কারণ কি এগুলোর কোনো ডিস্ট্রিবিউশন নেই। ওকে, এই জন্য তাদের প্যারামিটারও নেই। কাজেই আপনি কখন বুঝবেন আপনি নন প্যারামেট্রিক টেস্ট ইউজ করবেন? যখন দেখবেন যে আপনার ডেটাকে আপনি কোনোভাবে নর্মাল ডিস্ট্রিবিউশন অ্যাপ্রক্সিমেটলিও ফলো করতে পারেন না, স্যাম্পল সাইজ স্মল। ওকে, কাজেই যে লার্জ স্যাম্পল প্রপার্টি অফ নর্মাল ডিস্ট্রিবিউশন সেটাও তখন violated. So that is our background when you will use a non-parametric test. Interestingly, non-parametric test is an every counterpart of the parametric test. Okay. For example, if you want to test two means independent samples, okay, non-parametric test has a one. They call it Manrick mu test. If you want to test a pair t-test, that is dependent samples, non-parametric test has a one. Okay, that is, they call it Wilcoxon rank test. So those are things you need. That is, when in any way you cannot ensure that normality assumption is ensured, then you have to use this non-parametric test. This test have the obvious advantage of not requiring the assumption of normality or the assumption of homogeneity of variance. They compare medians rather than means. Okay, another criteria of non-parametric tests. As a result, if the data have one or two outliers, their influence is negated. আপনারা জানেন যে মিডিয়ান ক্যালকুলেশন করলে আউটলায়ার ভ্যালুগুলো লাগে না। কাজেই that is the point that in non-parametric tests medians are used. There are some advantages of non-parametric distributions, that it is readily comprehensible, very simple, easy to apply, do not require the complicated sample theory, no assumption is made about the frequency distribution. Since the socioeconomic data are not in general normally distributed, non-parametric tests have found applications in psychometry, sociology, educational statistics. Non-parametric tests are available to deal with the data which are given in ranks. Okay, so in general, the qualitative data we have to use these non-parametric tests. So one of the non-parametric tests is chi-square test. Okay, it is a bit different from the chi-square test we studied. There are two types of chi-square tests actually. The chi-square test for goodness of fit applies to the analysis of a single categorical variable, and the chi-square test for independence that we studied in your last classes, our relatedness applies to the analysis of the relationship between two categorical variables. Okay, the chi-square test of goodness of fit is a non-parametric test. Okay. Assumption testing. There are three assumptions you need to address before conducting chi-square test. Random sampling, independence of observation, size of the expected frequency. That is, you don't need to ensure that normality test. Okay, that is, it says. Random sampling means observations should be randomly sampled from the population of all possible observations. Okay. Independence of observation. Each observation should be generated by a different subject and no subject is counted twice. That is, you have to draw the samples independently. Size of expected frequency. When the number of cells is less than 10, or particularly when the total sample size is small, the lowest expected frequency required for a chi-square test is 5. Okay. So that is one thing you have to ensure while using that goodness of fit chi-square test. That is, your expected frequency should be at least 5. Okay. If it is not, there are methodology to make that at least 5. That is, you have to add the adjacent cells. Okay. So this is the chi-square test of goodness of fit. The test of significance involves the comparison between a set of actual and a set of theoretical frequencies. That is, one set of frequency is given, that is the observed frequency we studied. The latter having been obtained in accordance with the hypothesis we wish to test. This set of tests is called the test of goodness of fit. The calculation of theoretical frequencies given the form of the hypothetical distributions on the basis of observed frequency table is often referred to as the fitting of a distribution. That is, we want to say whether the observed frequency is fitting a particular set of expected frequency or not. Okay, so we will consider those expected frequency in general by assumption or coming from a distribution, Poisson distribution or binomial distribution, and so on. The formula here is used, the same formula, that y is the observed frequency and ei's are the expected frequency, and chi-square formula is as before we learned. This test statistic is distributed chi-square with k minus r minus 1 degrees of freedom. R denote the number of independent parameters related to the sample data in order to evaluate the expected frequency. Okay. In general, these are given in terms of the distribution. Example: the following table outlines the attitude of 60 people toward US military bases in Australia. So the exact observed frequencies are given here. Okay. Attitude towards US Army: in favor 8, against 20, undecided 32, it totals to 60. So these are actually the observed frequencies, and expected frequencies you can consider. For example, you want to consider with equal frequencies. Okay, 60 people, so say 20, 20, 20. Okay, you want to consider by assumption. You may consider that proportionate to the observed frequency. Okay, so that you can put that observed frequency and expected frequency value here and produce that chi-square, and then chi-square calculated is compared with the chi-square tabulated value, and the decision making is as before. So that is the chi-square test of goodness of faith. This one is sign test. Sign test is equivalent to a proportion test we studied earlier, one sample proportion. Suppose that paired or matched random samples are taken from a population and the differences equal to 0 are discovered, leaving n observations. The sign test can be used to test the null hypothesis that the population median of the differences is 0. Calculate the difference for each pair of observations and record the signs of the difference. The sign test is used to test the hypothesis that pi equals 0.5. This pi is the proportion of non-zero observations in the populations that are positive. Okay. The sign test statistic is S. S is equal to the number of pairs with a positive difference. Okay. Our goal is to find when we have two sample values like the pair t test, we only look for the sign of it. Okay. First sample থেকে second sample এর value গুলা individually আমরা subtract করব, বাদ দিব। Say xi minus yi আমরা আগে যেরকম করেছিলাম, ওকে, যে xi minus yi, ওকে, xi minus yi করে আমরা কিন্তু তার যে amount নিয়ে ইন্টারেস্টেড না, we are interested with the sign only. For example, xi যদি 10 হয়, yi যদি 8 হয়, তাহলে এটা হচ্ছে positive sign. Then we can consider that this is a positive sign. Again, x2 যদি 4 হয়, xy2 যদি 5 হয়, then it is a negative sign. Okay, so we will count the number of pairs with a positive difference. That is our test statistic. That S has a binomial distribution then with parameter pi equals 0.5 and n is the number of non-zero differences. Okay. So it will follow a binomial distribution table. Okay. So from there we can test our null hypothesis, whether null hypothesis pi equals 0.5 or not, and any alternative you consider based on whether pi is greater than 0.5 if you have that probability that x greater than equals s. Okay, আপনি দেখবেন যে কতগুলা x এর ভ্যালুর জন্য আপনার পাইটা 0.5 এর থেকে বেশি হয়ে যায়, 0.05 এর থেকে, তাহলে সেখানে আপনার ক্রিটিক্যাল রিজিয়ন হবে। Okay, for a two-tailed test it is actually 2 into that 5 values. So using that binomial table আমরা আপনাদেরকে দেখিয়েছিলাম এবং তার প্রত্যেকটা x এর ভ্যালুর জন্য, x বা y যা বলেন, তার ভ্যালুর জন্য p এর ভ্যালু গিভেন থাকলে আপনি n এর ভ্যালু বসিয়ে তার প্রত্যেকটার প্রবাবিলিটি বের করতে পারেন। Okay, so based on that you will decide whether that null hypothesis is accepted or rejected. Okay, so that is a sign test. We have an example here. An Italian restaurant close to a college campus contemplated a new recipe for the sauce used in its pizza. A random sample of 8 students was chosen, and each was asked to rate on a scale of 1 to 10 the taste of the original and the proposed new sauces. Okay, The scores of the test comparisons are shown in the next table, with higher numbers indicating a great liking of the product. Do the data indicate an overall tendency to prefer the new pizza sauce to the original pizza sauce? Okay, so that is the hypothesis, whether the new pizza sauce is greater than the original pizza sauce. Okay, so what is your null hypothesis? That it is actually equal. Okay, so P, that pi equals 0.5, that is, the liking is the same. But the alternative hypothesis is we have to prefer the new pizza, so it is greater than that 0.5. Okay, so what we have to do, we have to find the differences here. You see, these are the ratings out of 10. These are the ratings for the new source. So these are the differences. But scientists consider only the sign. Okay, -2, we consider the sign negative only, plus, 0, and there is no difference here. Okay, negative sign. So how many negative signs we have here? 1, 2, 3, 4, 5. Okay, and 1, 2, that is positive sign, is equals 2. 0 should be discarded. Okay, যখন দুইটা স্কোরই সমান, যে না আগে যে সস ছিল সেটার স্কোরও সমান, has put 7, new one is 7, so we got a 0 difference here. So we have to discard this value as it has no sign. So originally we had 8 score, n equals 8, but because of this tie value, that is because of the 0 value, we got n equals 7. Test statistic S equals number of positive differences, so it is 2. Okay, কেউ কোথাও বুঝতে না পারলে তৎক্ষণাৎ কোশ্চেন করবেন। ওকে, তাহলে s equals 2 হলে এখন আপনি এই s equals 2 এর ভ্যালুর জন্য বাইনোমিয়াল টেবিল থেকে p এর মান যেখানে 0.5 আর যেখানে s মানে x এর মান 2, তার জন্য প্রবাবিলিটি ভ্যালু ক্যালকুলেশন করবেন। ওকে, যেখানে n এর মান 7, x এর মান হচ্ছে 2। এখন আপনি দেখেন যে এই ভ্যালুটা 0.05 এর থেকে ছোট না বড়। যদি সেটা 0.05 এর থেকে ছোট হয়, null hypothesis rejected, otherwise accepted. So based on that you can make your decision. Okay, আপনারা বাইনোমিয়াল টেবিল প্র্যাকটিস করে অভ্যস্ত, কাজে আমরা আর সেখানে যাচ্ছি না। ওকে, আর কোনো কোশ্চেন আছে? Okay, next topic is Wilcoxon sign rank test. Okay, this is the counterpart of the pair t-test. আমরা আপনাদেরকে পেয়ার টি-টেস্ট পড়িয়েছিলাম, যেটাকে আমরা ম্যাচ পেয়ার টি-টেস্ট বলি, যেখানে আফটার এন্ড বিফোর টাইপের স্কোর থাকে, and we want to test the hypothesis that mu d equals 0, that is the parametric test. But here in non-parametric test we will call it Wilcoxon sign rank test. Okay, one disadvantage of the sign test is that it takes into account only a very limited amount of information, namely the differences. The Wilcoxon sign rank test provides a method to incorporate information about the magnitude of the differences between matched pairs. Okay, sign test এটা একটা old fashioned method, এটার আপগ্রেডেড ভার্সন হচ্ছে Wilcoxon sign rank test. Okay, what it actually do, that it can be employed when a random sample of matched pairs of observation is available. Assume that the population differences in these pairs sampled is symmetric, and we want to test the null hypothesis that the distribution is centered at 0. Discarding pairs for which the differences is 0, we rank the remaining n absolute differences in ascending order with type assign the average of the ranks they occupy. The sums of the ranks corresponding to positive or negative differences are calculated, and the smaller of these sums is the Wilcoxon sign rank test statistic T. Okay, so what you have to do, this sign rank test says that T is the test statistic. T is equals to minimum of T plus and T minus. T minus is the rank sums of the negative differences. T plus is the rank sums of the positive differences. Okay, n is the number of non-zero observation. So here we want to do that with an example here. Okay, what is that example? The example is discussed previously. That is, that original source and new source problem. We find the differences here. Okay, and here we are doing the rank. Okay, the rank is, you see, these are the differences, and we are ranking this. Okay, ranking this ignoring the sign, and 0 is discarded. So 1 is the first value, and we got 2 ones. Okay, so we put the first one A1 rank, first one, and second one A2. Okay, and the rank would be, for these two cases, the average of it. 1 আর 2 যোগ করলে 3 হয়, 3 কে 2 দিয়ে ভাগ দিলে 1.5. 1.5 should be attributed to the tied observation. Okay, কাজেই এখানে 1.5 আর 1.5 rank হলো 1 আর 2 নম্বর observation. 3 নম্বর rank আসে আমাদের 2, এই জন্য 2 কে আমরা 3 নম্বর rank দিয়েছি। 3 এর পরে ভ্যালু 4। ওকে, 3 এর পরে 2 এর পরে ভ্যালু 3, 3 কে আমরা 4 নাম্বার র‍্যাঙ্ক দিয়েছি। 3 এর পরে 4, 4 কে আমরা 5 নাম্বার র‍্যাঙ্ক দিয়েছি। 5 এর পরে কত? 4 এর পরে 5, 5 কে 6 নাম্বার র‍্যাঙ্ক, 5 এর পরে 6, 6 কে 7 নাম্বার র‍্যাঙ্ক। So we got these ranks. Okay, so you see we had only 2 values that are positive, and that rank positive we got 3. We are summing it, so 1.5, 1.5 is 3, and these ranks are actually for the negative differences. You see, 6, 3, 7, 4, and 5. It sums to 25. Okay, so we are calculating the T, that is minimum of 3, 25. So minimum of 3 and 25 is 3. So this 3 is our test statistic. Okay, do you have any question?
No, sir.
Fine. Then we can calculate the expected value of this T, that is actually n into n plus 1 by 4, and variance of T is n into n plus 1 into 2n plus 1 by 24. So based on that mu and sigma, we actually, for large n, we can calculate the Z approximately standard normal distribution, that is T minus mu T divided by sigma of T. If the number n of non-zero differences is large, T is the observed value of the Wilcoxon's test statistic, then using that standard normal table, you can decide whether your null hypothesis is calculated, say rejected or accepted. Okay, so you will get that z calculated from here and a tabulated value from the table with z alpha. So based on that, if your z calculated is greater than that z tabulated, your null hypothesis would be rejected. Okay, so based on that, your decision making will be done. Okay, so this is Wilcoxon's sign rank test. আমরা আপনাদের আগেই বলেছি যে আমরা যখন টেস্ট করব তখন সবসময় অ্যাবসলিউট ডিফারেন্স নিয়ে করব, তাহলে একই ফর্মুলায় আপনি সব টাইপের টেস্ট করতে পারবেন। ওকে, so that is actually the Wilcoxon sign rank test, that is also equivalent to pair t-test, mass pair t-test. Do you have any question? No. Okay. Yeah, so good that you have no question. Okay.
স্যার এখানে n1 n2 বলতে কি বোঝাচ্ছে একটু কনফিউজড হয়ে গেছে।
Repeat again.
এই যে একটু আগে যে ফর্মুলা দেখলেন n1 আর n2 ফর্মুলাটাতে এখানে কি এটা দুটো না স্যার এর পরের স্লাইডটাতে স্যার এটা কি আগে চলে গিয়েছে?
n1 n2 বলে কিছু নেই এখানে। কোনটার কথা বলছেন?
স্যার স্লাইড নাম্বারটা খেয়াল করিনি। আচ্ছা স্যার বোঝাতে বোঝাতে তো ক্লিয়ার হয়ে যাবে, এমনি কোয়েশ্চেন নেই স্যার।
ওকে, আমরা পরেরটাতে এখানে n1 n2 আছে, পসিবলি আপনি এটার কথা বলছেন। ওকে, this Mann-Whitney U-test is equivalent to independent sample t-test. Okay, so in non-parametric test, this Mann-Whitney U-test will test whether two independent samples are different or not. Okay, assume that apart from any possible differences in central location, that the two population distributions are identical. Suppose that n observations are available from the first population and n2 observations are from the second population. The two samples are pooled. The observations are ranked in ascending order with ties assign the average of the ranks as before. Let R1 denote the sum of the ranks of the observations from the first population. The Mann-Whitney U statistic is defined as U equals n1 into n1 into n1 plus 1 divided by 2 minus R1. So R1 is the rank sums of the first sample, okay, and R2 is the rank sums of the second sample. So in Mann-Whitney U test, that test statistic is n1, that is the sample size from the first sample, n2 is the sample size for the second sample, and R1 is the ranks, sum of the ranks observed in the first population. Okay, population that the sample, equation of the sample. Assuming that the null hypothesis is that the central locations of the two population distributions are the same, that is we are talking about, you see carefully, that we are talking about the null hypothesis is that the central location measure, mean was the location measure, okay, the central location measure, the central locations of the two distributions are the same. So that is the null hypothesis. We are not saying that mu1 equals mu2. There is no mu1 mu2 here. Okay, we have no means. Okay, but we are saying the central locations. So that is, you have to learn carefully that in non-parametric test we have no parameters here. We are talking about that central location, that is whether mean or say usually that is the median, but that is not denoted by any parameter because there is not any parameter here. Okay, so that is the mean. U has the mean U1 n1 into n2 divided by 2, and variance of U is n1 into n1 plus n2 plus 1 by 12. So for large sample sizes, both at least 10. Okay, so in non-parametric test, large sample sizes means at least 10 and onward. The distribution of the random variable is z equals u minus mu of u divided by sigma of u. Mean of u এখানে, sigma of u এখানে। এটা দেখতে পাচ্ছেন, এটা কিন্তু sigma স্কয়ারের ভ্যালু, এটাকে আপনি sigma u করতে হবে স্কয়ার রুট বসিয়ে। So this will follow approximately normal distribution. So if the z calculated is greater than the z tabulated, null hypothesis is rejected. What is your null hypothesis? Null hypothesis is the central locations of the two distributions are the same. What is the alternative hypothesis? Alternative hypothesis is that the central locations of the two distributions are different. Or if you want to test whether the central location of the first population is greater than second, or otherwise the central locations of the second population is greater than first, whatever. But your hypothesis should be set in words, not by any notation, because there is no notation here. Okay, decision making is as before. Follow our instructions so that your decision making will be easier. Okay, here is an example for you. Suppose that a study is sedimentary rocks. The following diameters in millimeters were obtained for two kinds of sand. Sand 1, these are the measures. Sand 2, these are the measures. Okay, so the problem is to decide whether the two populations are the same. If one is more likely to produce larger observations than the other. So write down your null hypothesis and alternative hypothesis and follow the steps for testing hypothesis. Okay, আপনার ডেটাটা আগে তুলে নেন, সবাই খাতায় ডেটাটা আগে তুলে নেন। 1 2 3 4 5 6 7 8। ওকে, কাজে আপনারা বুঝতে পারছেন এখানে 17টা ডেটা আছে নাকি 15টা, 7 8 15টা ডেটা আছে, 15টা ডেটার। তাহলে n1 এর মান কত আর n2 এর মান কত আপনি দেখলেন, এখানে 15, এখানে 14 পসিবলি, অথবা আপনারা গুণে দেখবেন। ডেটাটা তুলে নেন আগে, এরপর আমরা ফর্মুলা পেজে যাব যাতে করে আপনারা ক্যালকুলেশন করতে পারেন। ওকে
স্যার, n1 15, n2 14
লাইক দিস, যেটা ভ্যালুগুলো গুণে আসে। I'm not very good at counting, but more importantly, what you have to do, you see, you have to suppose that n observations are available from the first population and n2 are from the second population. The two samples are pooled, okay, and then the observations are ranked in ascending order. আজকে কি করতে হবে আপনাকে, এখানে 15টা ডেটা আছে, এখানে ডেটা আছে 14টা, এদেরকে আপনি মনে করেন যে এটা একটা ডেটা, এরপর এদেরকে আপনি ছোট থেকে বড় আকারে সাজাবেন, র্যাঙ্ক করবেন। ওকে,
জি স্যার।
Then you have to find R1. R1 is the sum of the ranks of the observation that are coming from the first population. That is the work you have to do. Okay, so from smallest to the highest, you should order it first, okay? And then put ranks 1, 2, 3, 4 up to that 29. আশিকুজ্জামান কৌশিক, আপনি ক্লাস তো নিয়মিত আছেন না? আশিক, আপনি কি ক্লাসে নিয়মিত থাকেন? ওকে, কারো কোনো প্রবলেম হলে কথা বলবেন। ওকে, যার ক্যালকুলেশন হলো আমাদেরকে রিপোর্ট করবেন। আপনারা চ্যাট বক্সেও লিখতে পারেন যে আপনার R1 এর মান কত হলো বা U এর মান কত হলো। Then you have to calculate this expected value of U by putting N1 into divided by 2 and also the variance of U and then the Z value. Okay. So যার ক্যালকুলেশন হয়ে গেল, R1 টা আমাদের চ্যাট বক্সে লিখবেন, যাতে আমরা অন্যদের সাথেও মিলায় দেখতে পারেন যে whether your calculation is going to be right or not. কেউ পারলেন R1 বের করতে? কোথাও আটকে গেলেও কিন্তু কোশ্চেন করবেন। ওকে, Tanjim got R1 equals 162. We don't need R2. Okay, Tanjim, we don't need R2. We need only R1 and then expected value of U and sigma of U and Z. Okay. Now calculate expected value of U and sigma square of U and then Z. ইয়াসিন আরাফাত, আপনি কি ক্যালকুলেশন করছেন? ইয়াসিন আরাফাত, আমাকে শুনতে পাচ্ছেন? অনলাইন ক্লাসের এই হলো প্রবলেম যে আমরা সবাইয়ের সাথে কমিউনিকেট করতে পারছি না। এখানে দেখতে পাচ্ছি যে কয়েকজন পার্টিসিপেট করে ক্যালকুলেশনে, বাকিদের কি অবস্থা? Okay, so we got U equals 168, U equals 168, Z equals 2.75. What about others? আমরা দেখেছি এখানে যারা ক্লাসে পার্টিসিপেশন করছে ক্যালকুলেশনে, এই নামগুলা অল্প কয়েকজন। বাকিদের বিষয় নিয়ে আমি খুব চিন্তিত। তারা কি ক্যালকুলেশন করছে না? ইয়াসিন আরাফাত, আমাকে শুনতে পাচ্ছেন? ইয়াসিন আরাফাত, কি যেন নাম, ইয়াসিন আরাফাত সামথিং। ওকে, এনিওয়ে, তো আপনারা মানে লেকচার দেখেও ক্যালকুলেশন গুলো করতে চেষ্টা করবেন। কোনো প্রবলেম হলেও আমাকে ইমেইল দিবেন। জেডের ভ্যালু ক্যালকুলেশন করেছেন সার্ভার 2.75। ওকে, সার্ভারের অন্য আদার ভ্যালু নেই, একবারে জেডে চলে এসেছেন আপনি। গুড। আর কেউ জেডের ভ্যালু ক্যালকুলেশন করলেন? যারা সাকসেসিভ তানজিম দেখিয়েছেন, তানজিম জেডের ভ্যালু কত হলো? ওকে, ওকে, then z equals 2.75। আপনারা যদি এখন এই ভ্যালুটা 5% জেড ভ্যালুর সাথে কম্পেয়ার করেন, যেটা নাকি 1.96, তাহলে দেখতে পাচ্ছেন যে আপনার ক্যালকুলেটেড ভ্যালুটা বড়, কাজেই নাল হাইপোথিসিস রিজেক্ট হবে, যে central locations of the two distributions are the same. Okay, কাজেই এখানে যে হাইপোথিসিসটা আপনি ধরলেন, যে that is one is more likely to produce larger observations than the other, সেটা হচ্ছে আপনার, যেহেতু এখানে ওয়ান ওয়ে হাইপোথিসিস, এজন্য ফুল আলফার ভ্যালুটা হবে, ফুল আলফার ভ্যালু 5% দিয়ে জেড এর ভ্যালু যেটা আসে তার সাথে কম্পেয়ার করতে হবে, কাজে আমাদের নাল হাইপোথিসিস সেই ক্ষেত্রে রিজেক্ট হবে। ওকে, অল্টারনেটিভ হাইপোথিসিস টাই অ্যাকসেপ্ট হবে। এই ডিসিশন আমরা পেলাম। ওকে, দিস ইজ হাউ non-parametric test can be done based on this problem. Okay, আমরা এই প্রবলেমে দেখেছি যে এখানে যে ক্যালকুলেশন, সেই ক্যালকুলেশনের সাথেও পসিবলি আপনাদের ক্যালকুলেশন মিলে যাবে। ওকে, তো আর কোনো কোশ্চেন আছে? আজকে এ পর্যন্তই। বাই বাই।